Paper ID 1372, Internet Traffic Classification using CNN Architecture VGG 16. Miss Manasi Shahapurkar.
Okay, good afternoon, everyone. So my topic is internet traffic classification using CNN networks. So I'm Manasi Shahapurkar from College of Engineering, Pune. I'm an MTech student. So my research PPT will contain introduction, problem statement, objectives, methodologies, and outcomes. So problem statement was to design a image-based classifier using CNN to analyze malware internet traffic. So basically, what is a internet traffic classification? So the purpose of my research was to differentiate any malicious or malware networks from normal networks, right? So whenever we operate our laptops or we connect our laptops to some lane or internet or Wi-Fi's, so there is some exchange of packets through internet. So whenever a network is being used, there is some malicious activities going on unknowingly. So that what is the main objective. So traffic classification is being based from network anomaly detection, network based intrusions, or to identify malicious use of networks. Thus, this research plays an important role in network security domain. So, causes of or why we need internet traffic classification is because we share files. There are some online gamings, peer-to-peer applications, multimedia streamings, and unexpected throughputs. So, objective was to detect suspicious activities and to classify network from normal to malware networks. So this was my some previous studies, like various classification has been done based on knife bias, some support vector machines, and every research similar to mine has some or other limitations. So because of which I chose some other ML based algorithms. So previously, what features were used to classify internet traffic? So first were port number based and second was flow based. So port number is basically uh, given to every application, and it is being listed in internet assigned number authority list. But why we don't use this kind of port based, like only port based number classification? Because some application disguise themselves as some other, like for example, Skype clients can disguise themselves as STP by using port 80, right? So doing some illegal or malware activities through port based is possible. So because of that, we cannot classify on this basis. Second will be flow based or packet based. So whenever we connect on internet, there are some sending or receiving of packets. So based on some internet travel time or packet size or intra size, this classification has been done. But what are the drawbacks of these two features is that we have to hand design the features. Exactly extracting and mapping features is not possible. Lack of variety and shareability traces is there. So yeah, so as I told, the previous rule based approaches were port based and the packet inspections. And other than that, currently in my research work, what I have been used is statistical and behavioral based. So this is how the flow of my research goes. Like, well, first we will be capturing the packets, that is files from internet. Then we'll be reading that traffic data. We will be pre-processing that raw data. We'll give that input for feature extraction to a CNN model. Then we'll be predicting our test models. So how we'll be reading our data? So for that, I have used a Wireshark toolkit. There are various packet capture tools nowadays, but one of the most visible is Wireshark tool. So it performs hundreds of inspection of protocols, and it is very easy to use as well. The only thing is that it captures a packet which is known as PCAP files to support networks. So those files cannot be sent to our CNN model. So before that you have to either create that raw data into array size or some image size. So for that purpose we have to give our pre-processed data. So this was one of my initial research for port based and packet based. So as you can see, using Wireshark, I was able to distinguish various packets on my system, but it was not sufficient for the research. So that's why we jumped onto pre-processed raw data. That was once I received the data, I have to because being captured from directly from the net, it was tremendously large data. So I have to split that pcap file into smaller parts, then I have to clear it. Why do I have to clear it? Will see as my slide proceeds. Then resizing the data, and then after that final, that is image generation. So traffic splitting is like because of huge pcap files, we have to split that into smaller files using split cap tool. Then I have to do it in a 5 tuple way. So what 5 tuple way is? Source port, destination port, source address, destination address, and protocols. So these five are the basic features I have used for my classification. Then after that, splitting my data, I have to clear the data. That is removal of the all empty files and duplicate files. As some of the packets have zero application layer, as a result, the bean files are empty product. So that would be a very waste of time to give such empty and unuseful files to my model, because of it will extend my training time. So after that, I'll resize my final data set so that it can easily convert it to a grayscale image. And once, as you can see here, I converted my raw data, which whatever I have collected from Wireshark, into grayscale image. After that, once my as you can see, once my uh, grayscale image has been obtained as an output, I'll give that to my CNN architecture. So I have used here is sorry, I have used VGG16 architecture. Uh, at the end of that, I have trained my model with convolutional layer, pooling layer, and fully connected layer. So I then accelerated my whole process using high-end processor with 6 physical core and 12 logical core. 12 logical core means that I can work parallelly because of 12 threads working simultaneously. So it give me a huge speed or acceleration to my training model. And after that, as you can see, there is model accuracy and model loss. So I was able to predict and accurately tell what kind of network is there. That is it a malware or is it a normal data at the end of my research. So this is on system 2 similarly. So basically the network classification was done on VGG with the architecture of VGG16. PCAP files were streamed from Wireshark and then processed and given as to my model, and accelerated with a multi-core processor with an accuracy of 99%. So these are my references. Yeah, thank you.
Okay, Manasi. Come to the result.
Just a minute, sir. Yeah, yeah, sir. So these are the graphs for my results.
Did you compare with the previous work?
Yes, sir. So previous work were giving us around 80 to 85% of accuracy along with some other features. What features I have selected was 5 tuple, but they just selected for just one, like either port based or some flow based features. So I combined those all, and this was my results with 100% accuracy and minimum model loss.
Okay, okay. Because you have not put up a in tabular form the previous work result and yours. So that's I asked that one.
Okay, sir.
Okay, no issue. You can stop your screen
Right.
sharing.
Thank you, sir.
Welcome.